Hi, Ankur. Good evening. Hi, Ankur. Can you hear me?
Hello,
Ankur, can you hear me?
can you hear me, sir?
Yes, yes, yes.
Oh, great.
Clearly. Good evening.
Perfect. Sir, happy Diwali.
Thank you. Same to you.
Tomorrow we have a break
Yeah,
of
yeah.
teaching.
Yes.
6 से शुरू है ना सर अभी?
6 बजे से हाँ.
कितने लोग हैं आज बोलने वाले?
एक one speaker.
कौन, आप की सुरजीत?
हाँ.
आप
नहीं
हैं
नहीं.
सुरजीत कौन?
We have an industry executive ना. Miss Parul
अच्छा
Pandey. So Dr. Surjit will moderate the session. I'll just say hi and then I will watch.
अच्छा.
Good evening, Miss Parul. Sanjay here.
Hello, good evening, sir. How are you?
I'm good. I'm good. How are you?
I'm also good.
Yeah. Apologies for hounding you during your vacation.
Oh, no, my vacations are already over. So now pretty much you cannot even go anywhere now.
Yeah.
So
Yeah.
it's like you have to stay at home whether it's a festival or not.
Mm-hmm. Yeah. Yeah. Thanks for accepting this invite.
Oh, you're welcome. I always like interacting, especially when they are students.
Mm-hmm. So we'll just give couple of minutes. I'm expecting some more people to join Zoom, and then we will start. Okay.
Sure, sure.
Good evening, Venu sir.
Hello, Sanjay. Ma'am is there?
Yeah, so Miss Parul has already joined. I'm waiting for Dr. Surjit.
Yes, yes. You want me to call him, sir?
Yeah, please.
One second.
So Parul, Dr. Venu Gopal is the head of the department for marketing.
Hello, sir.
Hello, ma'am. Hello. How are you?
I'm good. Hope you're also doing well.
Yes, ma'am. Yes. Okay. Thank you so much. Thank you.
Sanjay sir, good evening. Venu sir,
Good
yes.
evening, sir. You are here. Okay.
Yeah, I'm here.
Welcome. Yeah.
Miss
So,
Parul, hi, good evening.
Good evening, sir. How are you?
Yeah, doing fine, thank you.
so right, ma'am, let's start. So, welcome to this session. Welcome to IBS virtually. And thanks for accepting our invite. So, it would be a great learning for students, hopefully. So, I will hand over the proceedings to Dr. Surjit. He is from the marketing department. Over to you, Dr. Surjit.
Thank you, sir. So I'll let me welcome Miss Parul to this session, and gracefully she has agreed to take this session for us and for our students. So um, before I start, let me read out her brief profile, and then I'll hand over the session to her. The topic is predictive analytics and industry perspective, uh, talking about the application side of it. And her profile, brief profile goes like she is an award-winning data scientist and very well known in data science community. And also she is an excellent speaker. Currently, she is working as data scientist and evangelist at H2O Artificial Intelligence AI. She writes and shares updates on machine learning tools, as well as she puts together roundups about more general machine learning and artificial intelligence related things in the tech industry. So when she is not into her core activities, she is very active on Kaggle, and her LinkedIn profile also has been shared with the students and other participants in this session, so they can visit her profile, and if they feel like, they can always try to approach her for some guidance anytime required. Thank you very much and welcome to this session. So let me hand it over officially now to Ms. Parul. So please proceed.
Thank you so much. And firstly, I'd like to thank you all for having me here. It's always a pleasure to interact with the academia because most of our time goes in interacting with the industry. So it's great to have an experience of both the sides. So with this, I'll just quickly share my screen and just let me know if you are able to see my screen.
It is visible, Parul. Go ahead.
Okay, thank you so much. So hello and welcome everybody to this session on predictive analytics and industry perspective. My name is Parul, and I work as a data scientist come evangelist at H2O.ai. So before we start, let me give a brief introduction. Already, I have been introduced, so I'll just quickly put down a few points. So I work, as it was already mentioned in my bio, I work as an evangelist, and what essentially an evangelist does is acts as a bridge between the company and the community. So I help people understand what we do at H2O.ai and also how machine learning is used in our company and how we enable other companies to essentially use our products and in a way democratize artificial intelligence space. Academically, I'm an electrical engineer. I graduated in electrical and electronics engineering from National Institute of Technology, Hamirpur in 2009. So it's been more than a decade in this field now. So when I'm not doing my evangelizing role or a data scientist role, I'm active in Kaggle. So I recently became a Kaggle Grandmaster. And for the ones who are not aware, Kaggle is a data science platform. It's a Google company. And it's a place where about millions of data scientists, they interact with each other. They compete on machine learning problems. They share their codes and they share data sets and also discuss on anything related to data science. Apart from all this, I am very passionate about helping women and people of underrepresented groups to actually make a mark in the STEM sector. So I am the founder of a group, a non-profit group called Women in Coding and Data Science. And our mission is actually to help people get into not only data science, but coding, programming, and anything related to the STEM sector. And we're very proud to have collaborated with the government of Andhra Pradesh to help mentor female students in about 13 engineering colleges in Andhra Pradesh. So me and along with other volunteers, we are actively working on this. And I share my data science knowledge with the people, mostly on Medium blogging platform and my own website, that's parulpandey.com. So I'll just tell you a little bit about my company because it will set the expectation of the session and also why I thought this session, it would be interesting to actually share this session with the students. So H2O.ai is a company and that company has a lot of products. So the two main products that we have currently is H2O open source and driverless AI. So what H2O open source is, it's just a machine learning distributed library. So it's just similar to scikit-learn for the ones who are aware of it. And it's completely open source, and communities and people all around the world and companies too, they use H2O for solving their machine learning problems. On the other hand, we have a product called driverless AI, and driverless AI is an automated machine learning platform, which means that it does complete end-to-end machine learning. You feed in your data, you feed in your problem, and then the platform does everything for you. And not only it does the whole machine learning stuff, it also helps you understand why the machine predicted a following result. It has machine learning interpretability features. It has auto visualization. It just visualizes seeing the kind of data that has been fed into the system. So both of these products are used extensively by companies around the world. And when companies use these products, we interact with them regarding their problems, because not always we have a machine learning problem just set as, this is my machine learning problem, these are the parameters, and you have to find this. We always have weird and vague problem statements, and those statements have to be converted into a business problem and a machine learning problem. And it is because of my interaction with a lot of companies, with a lot of vendors, and maybe even individual data scientists working in my company and outside. And all those experience I would like to share with you all today. If you're interested to look more into what kind of work we do, you're more than welcome to visit our website. So the sort of use cases that we, like I was telling you, that we deal with, it ranges from all the sectors: financial services, healthcare, telecom, marketing. So today there's no industry which has been not touched by analytics, which has not been touched by machine learning. And everywhere companies want to utilize and they want to automate that entire stuff to obviously get better at what they are doing, and also in this competitive market to get an edge from the others. So if you'll see here, this is just one screenshot or one slide from my company slide where we are helping the other companies to utilize our expertise in machine learning. Okay, so for the ones who are aware, this slide, or you could say the picture on the right-hand side, is from a movie called Moneyball. And this is a very interesting movie. And for the ones who are like analytics enthusiasts, I think this is a must-watch movie for them. So this movie is actually based upon a book, and it's a real-life experience of a person called Billy Bean. And what is so special about this movie is that how statistics, or you could say how automating stuff can actually help you just transform the entire problem that you're working on. So interestingly, what happens in this movie is that Billy Bean, which is played by Brad Pitt in the movie, is a manager of a baseball club called Oakland A's. And just like clubs and soccer clubs that we have today, every club wants the best player. And how do you get the best player? You have to pay some hefty amounts to the players. Only then they'll come to them. But what do you do if you are like Oakland A's and you have a very tight budget? You don't have money to give. And if you don't have good players, you will not win. So the entire ideology that time was you can only win if you have good players. But what Moneyball shows you that it's not the case. Oakland A's hired, you could say, they hired Peter Brand, and Peter Brand was a fresh graduate from Yale, and he was a statistician. And he had a very different idea about winning. So he says your goal shouldn't be to buy players. Your goal should be to buy wins. And in order to buy wins, you need to buy runs. So he broke down this entire problem as it's the runs which decide which club is going to win and not the players. And how did they do this? They took out all the historical data of the previous matches that were happening, and they found something very interesting in that data. So what they saw was that most of the teams were focusing on batting averages that time. The person which had the best batting average was paid the highest. And what Peter Brand actually found from all the analysis of the historical data was that the batting average wasn't even important, and it was not the deciding factor for winning the matches. On the other hand, what was important was the on-base percentage and the slugging percentage. And interestingly, no other club was actually focusing on that. And they had so what he suggested was that there were some skills which were undervalued, and there were some skills which were overvalued, but the skills which were overvalued were not even important in winning. And this whole, what happened after that was just history. They had this winning streak. They went on to win so many matches. And this example of Moneyball is a testimony to the fact that how statistics can just, help an underdog win. And today, a lot of other sports clubs, and be it soccer, be it probably in cricket, they utilize this Moneyball idea. And if you'll see today, IPLs, everywhere you have people sitting with laptops studying all the historical averages, the batting percentages, the bowling, the fielding, and then they decide, which player is important. And the whole idea about having statistics in sports sort of just to revolutionize the entire industry. And it's not only in Moneyball. This year, NFL, National Football League, they also organize Kaggle competitions. And if you see, this is the recent competition, and the prize money is $75,000. And the fact that they are giving so much of money for just one competition in Kaggle also tells you so much about the use of statistics. Not only in sports, but for them, it's also more about business. if you'll see there, you'll see it's written, you'll be provided a game, play, and player level data, including the position and speed on players as provided in the NFL's next gen stats data. And you were to predict, which teams had the most chances of winning. So it's like statistics, predictive analytics, that they have just become a part of our lives, and they are being utilized in every field if you go today. And so this makes it a very important subject to actually develop on. Again, if we see Waze is a very popular traffic app, and it uses predictive analytics. So these are some of the use cases. I'm sure you're aware of most of them, but it's just to give a brief overview as to which other industries which have been affected by predictive analytics, right from calculating your estimated time of arrival at your destination, or of course, Amazon uses recommendation algorithms, state-of-the-art recommendation algorithms, and they know you better, you know yourselves. Netflix, I think Netflix forces you to binge watch, gives you suggestions one after the other. And if you were to just look back, I think the weather data or weather predictions are the very primitive use cases of predictive analytics that we always know that they exist, but we sometimes don't even bother that, these all these apps that we use so much on our phones on day-to-day are using the data around us, and then they're giving us recommendations. So having said about these examples and starting where it is used, it'll be good if you just looked at just a textbook definition of what predictive analytics is. And I really found this nice small video which explains it very well in few sentences. I think the volume is not audible.
No, it's not, Parul.
Because I think I should have. Anyways, we could just skip it. So this just tells you. All right. Also, I think I will have to switch on my video to just save on the bandwidth. Is that all right? I could come back after. Okay. So what is predictive analytics? Having said so much about this, so the textbook definition goes like this, that predictive analytics describes the practice of using historical data to predict future outcomes. And typically, historical data, why is historical data needed? It is to create some algorithms. And so we pass on the historical data into some predictive algorithms, and we create a model. And we can create different types of models depending upon, do we want more accurate models? Do we want more false positives, false negatives, and so on? But the idea is to use that created model to then use some new data and make predictions on the new data. So historical data creates a model, and that then model makes predictions based on any new data that comes. And this very simple diagram explains the whole concept of predictive analytics. Now, depending upon the use case, you select the kind of algorithms you want, depending upon the problem that you have, whether you want to classify things, like you want to differentiate between whether your email is spam or not spam, or whether you want to predict what is going to be your sales, the number of sales, or what is going to be the price of your stocks. So depending upon that, you have different algorithms. Now, why does that predictive analytics today has become such a hot topic? And because every company wants profit, and it's not that the companies which are coming like after 90s are only concerned about profits. Companies used to bother about profits even like few years, 20 or 30 years back. The important thing is that today we have access to like humongous amount of data. And if you were to look like 30, 40 years ago, you would see that more emphasis was given on sampling. So we used to do sampling, and then based on the results of that sample, we would predict it for the entire population. But today, I think the rise of big data, the rise of cloud infrastructure has made it possible to actually perform analytics or machine learning on the entire data. You have so much of storage available that it is not a big deal. Secondly, there's an increased amount of competition. In the same area, you have like thousands of companies which are, for instance, you look at e-commerce, in India itself, you have Amazon, Flipkart, Snapdeal, and so many others. And so the competition is really tough. And so it makes a lot more sense that the kind of recommendations that a company gives should be accurate, and you sort of today do not have margin for error. And lastly, of course, the cutting edge technologies. Earlier, I remember GPUs or graphical processing units were only used for playing video games. Mostly the people who were interested in that had GPUs installed computers, and that computers were kind of different from the normal working computers. Today, GPU is becoming just mainstream. There are students who are actually buying GPUs. There's been a lot of talk. People now they want to know as soon as the new GPU comes from NVIDIA, they're really interested about it. So things like this are becoming mainstream. And because of this gives access to not only a lot of data, but a lot of computing power also. And now, because you have access to all these technologies, you can apply analytics, predictive analytics, and you can carry on predictions and so on. So again, analytics has a lot of types. It could be predictive, descriptive, prescriptive, but evidence suggests that predictive analytics is the most frequently used type of analytics across several industries. And the reason is pretty much obvious that every organization would like to forecast a demand for the products they sell. And in turn, it translates to business, revenue, and that is the final deal, actually, what matters. So hence, companies are pushing for more and more usage of data-based predictions rather than just simple gut feeling. So to just understand it more and give a more concrete understanding of this entire concept of predictive analytics, let's just start with a business problem. And this is not just a toy problem. This is a problem that we actually have customers who bring it to us, and this is a very common problem. And I think as for H2.ai, about 50% of our customers, they actually belong to finance sector. And one of the greatest problems for them is the credit default prediction. So for the banks, a bank would always want to optimize its loan underwriting procedure. And let's say there is a bank, and currently it has filters on its loan applications, and those filters will automatically reject the riskier ones, because no bank would want bank would want to give loan to somebody who will not return it. But even though banks have things in places, they still approve too many applications that run into repayment issues, and that's dangerous for a bank. So predictive analytics, if you look at banking industry, so predictive analytics is used by banks to predict which customer will default the credit card payment or the loan payment. So it's a very classic case of a classification problem where you have to predict whether a person is going to default on the loan or not. And not only this, banks today don't want just to know which person is going to default on the loan. They also want to know what makes a customer actually default their payment. What is the reason? Because if a bank knows the reason, it can then work on that reason maybe, and that will help a person to repay the loan, because a bank wants the money in the end. So if you are working in such a bank and you are a data analyst or a data scientist in such a bank, the first thing, even though this problem appears to be very simple, that you will just get the historical data of all the people and you just have to predict whether they will return the loan or not. It's not that simple. You need to collect your data. And this data is the most difficult part, actually, to collect the right amount of data or the correct data which will go into the model. So you could say for this case study, there could be three different kinds of data that you can collect. It could be firstly the applicant demographics, for instance, such as age of the person, the salary, the employment length, and the home ownership. So this could be applicant-based data. There could be loan demographics, such as the amount of loan, the term for which the loan was taken, the interest rate, and the reason for the loan. So you'll have the second set of data. And the third one, and a very important one, would be the risk factors. So like the number of public records the person has, credit card delinquency, or even bankruptcy. And 70%, of the data fields that are collected by companies, they consist of such risk data. And when you have all these different sort of data, you combine the entire data, and now your goal is to create a predictive model to identify the bad loans from the good loans. But if you're going to look clearly here, we don't have any column or any row which will tell you whether a person is going to give back the loan or not, because obviously this is something that we want to predict. But what we're going to do is we're going to use this data, we're going to use the relationship between all these factors or all the data columns, and then we're going to find out whether the person, how much probability that person has of returning back the loan. Say, for example, a person who has a good job, he's earning well, he already has a house, and he hasn't been involved in any other credit default. He has more probability of returning back the loan than the person who actually doesn't have any income source. And that way, when we get those probabilities, we can then decide whether we should give loan to a person or not. And this is one of the mostly used use case that we have today, because working in banks are actually going through a lot of crisis, and they have to make sure, that the money that they give should return back to them. So when you are creating a model like this, and when you are working as a data scientist, you have to not only identify whether a person is going to return back a loan, but you also need to answer such questions. You have to segment the loans into different categories using this information that you have. You can sort the customers into different demographic data, people who are living in urban areas to the people who are living in rural areas. Then you have to discover patterns among them. And so your study is not only just limited to identifying who is going to return or not return the loan, but you also have to look into other features and other ways in which you can segment those people. So this is never just a single-ended question. It has a lot of different parts. And when you work on such things, you work in a team, and your team comprises of people with different backgrounds. So they're going to be people who will be great at algorithms and stats, who will help create a model. But there will also be people who will be from a domain background of finance or banking. And I think those people are the most sought after people in this area of predictive analytics, because the domain experience is something that is required. And this is finance, so you require people with banking experience. If you're in manufacturing, you would want people from manufacturing background, and so on. So you not only have to have the statistical prowess, but you also have to have an understanding of the domain in which you want to work. So what are the other use cases of predictive analytics? So lead generation, again, enhanced marketing efforts. You could identify future trends. For instance, you see a possibility that in 6 months, the demand for this particular thing will grow, and you start working. You can also identify growth opportunities with the help of the data and the analysis that you do. Customer churn, again, identifying which customer is at the highest probability of leaving maybe your job, if it's HR, or you're leaving your service, if it's about service-based company. So how predictive analytics has transformed this entire industry or the business perspective? Earlier, we used to have just mass branding, just one size fits all. Today, that thing has changed. Today, we have individualized experience. Amazon gives you the recommendations given by Amazon or Netflix and Amazon Prime to one person is entirely different as compared to the other person. And because not all the persons are going to have the same choices. And now it's all about real time. It's individualized experience. Earlier, it used to be daily risk analysis. So just once in a day, the daily risk report would come out, that would be sent to all the departments and so on. Today is just real time because you cannot afford to miss the details or surveillance even for a second. If you talk about hospitals, earlier it used to be mass treatment, just same thing for everybody. Today you have personalized healthcare, and personalized healthcare has actually truly transformed the healthcare industry. Healthcare itself has turned into an industry, and you provide personal healthcare depending upon the vitals of a person. And there may be chances that one person needs more healthcare than the other, and then depending upon that, the insurance is decided, and that's how this whole industry is working. Customer service. Earlier, you used to call a customer and you would wait, and your call would be then sent. You had to go through that complete voice assistance, and then you would be transferred to an executive. Today, for instance, if you look at Big Bazaar, Big Basket, for instance, so Big Basket is a grocery outlet, and if you have an issue with them, or maybe something is not delivered, you have an automated chat there. You just fill, and as soon as you just fill it there, you get the money is refunded back to your account, and it's just instant. And it's a personalized quality of service. You don't have to wait. You don't have to write emails. And this way, how the world is transforming. Even though a lot more is required, but some companies are just moving forward. The ones who are able to adopt analytics and machine learning into their workflows. And this is what is dividing industries today. So when we talk about, so this is what we talked about till now. We talked about predictive analytics, the use cases, which industries it's impacting, and so on. How can a company which is currently, thinking about adopting predictive analytics in its workflow, how should it go about implementing it? And it is not that easy as it sounds, because there are some 5 important factors that you need to firstly understand. So the first thing that you have to do is you have to identify the business problem. Any problem or any pain point that you have to identify. Whether your problem is that a lot of high attrition rate in your company, or your sales are going down, your profits are going down. So you have to understand what is your pain point and business problem. And that business problem has to be converted into an analytical problem. So once you know the problem, you will sit down, you'll brainstorm it with your company executives and people. And then you want to create a hypothesis on what is the cause of it and what is the action that you think you can take. And there'll be a lot of actions that you could take. And because you think that these are the actions that you can take, that has to be backed by data, and not just, I feel we should go by this or we should go by this. I think the gut feeling or the way that decisions were taken few years back cannot do much justice to the problem today. So now you have to translate that business problem to an analytical problem. And this is where a lot of experience or expertise is required. And it has to be, this whole translation has to be done by a team which works together. And like I said, it has to have domain experts, it has to have statistical experts, programmers, coders, and CEOs, CXOs, and the executives and the business suite people. Together, they have to brainstorm and decide that this is the problem, and we think these are the causes of it, these are the actions we can take, and this is the way the problem should be formulated. And once it's done, you need to collect the data. And that data, you have to make sure that you collect it internally, externally, feedbacks, reviews. For instance, if you look at Amazon, it not only collects data from the reviews that we put on the site. After you buy a product, it sends you personalized emails and asks you, how was your experience? How would you rate us on 1 to 10? And that's how it starts collecting data from a lot of multiple sources. And then you have to create a model, and then the whole pipeline is built. And once it's done, you have to make sure that that solution actually is understood by the stakeholders or the people who are going to use your product. And so you cannot create a product which is then not understood by the business users. And one thing which is not mentioned here is you also have to make sure that what you create is understood by people, common people, and the regulators. Because if you're working in financial and insurance sector, then you also have to keep in mind that you just cannot use a solution and say, our model has predicted this. You also need data to support it, and a lot of regulations had come into place, GDPR, and after that things have become really difficult because we've also seen it. And machine learning interpretability has emerged as the new sector in analytics, where you also need to explain not only that this is the decision, this decision was taken by a model, but why this decision was taken by the model. Because there was a recent case which was respect to an Apple card, where it was identified that the credit limit for women was way less than that of men, even though the women were buying a lot, and this had actually caused a furor. And when they looked back into the data and the models, okay, I think there's some background noise. Okay, and when they look back, they said the company was actually who were actually outsourcing the models to Apple. They said that gender was not even a factor that they had taken into the model. They said we have taken all different sorts of you could say features, maybe the buying capacity, but gender was never the factor. So how was that the model? You're saying that it is biasing towards females and male customers. And what after it was found out that interestingly, even though gender was not there, but what it was probably the kind of stuff that people were buying. And because of that, what were the stuff they were buying, it had actually identified that what could be women and what could be men. So there were correlated features in the data set. So you have to be very sure that you're not using a biased data set, because then you're going to have a hard time with the regulators. So this is so you just cannot rely only on what the machine learning predicts for you or what your model predicts for you, but you also have to put human in the loop too. So like I said, there are a lot of techniques for predictive analytics that you can use, a lot of them. So you use either classification model when you want to differentiate between two things, whether this is going to fall in one category or two. Like I said, whether you're going to return the loan, yes or no, true or false, spam or not. Regression models are used when you have to predict continuous variables like sales or stock prices, and so continuous numerical variables. You can also use neural networks, which are used a lot today. Deep learning networks also. Then you have time series algorithms where you want to predict things which have a time factor in them. And a very important one is text analytics, your natural language processing techniques, which are used for analyzing the text and making sense out of the text. So you have to use a technique based on the use case that you have. Interestingly, today, we are in such times where we have a lot of tools available for predictive analytics. So if you want to create something your own, you want to create your own model, you could use the Python or the R ecosystem that's available. But if you are a company or you're working for a company which doesn't want to create something of their own, but they want to use the expertise of others who've already created state-of-the-art stuff, so that is also available. And the few notable ones are like you have the Google AI platform. Such platforms, you have to pay for them and you can feed in your data and they have all the state-of-the-art facilities available. They will do the analytics for you and give you the result. Similarly, SAP Predictive Analytics is also a service. So software as a service, these are, you could utilize their platforms. You don't have to create anything from scratch. And this is particularly useful for industries which are pretty new and they do not want to hire, they do not want to create a team from the scratch. So they basically buy the products and they ask their team to learn how to use these products. Similarly, we have IBM's predictive analytics platform. This is H2O's platform called Driverless AI. This is also used by companies. Alteryx, Dataiku, Data Robot. So these are one of the common names, not all of them. And these are the tools that you can use to perform these analysis and get reports, get answers, get predictions. So this was a general overview over what predictive analytics is, how do you use it to work on a problem, how do you create a problem, and how do you fit it into an analytical pipeline. Now, the next part of this presentation, I will focus on how actually companies are using predictive analytics to change the way they are doing business. And what this is just, I've put down what is my experience working with the different companies and in what sort of help or what sort of expertise that we provide to companies. And when they want to solve some use cases using analytics. So overall, these are some of the sectors where we are working, and we've been working for like the past 6 to 7 years. And the sectors range from financial, insurance, marketing, healthcare, telecoms, manufacturing, retail. And all of these sectors have a lot of use cases. So every sector has its own different use case. And I'll quickly run you through some of the important use cases that they are, and you'll be surprised to see how predictive analytics is sort of being used in so many different industries. So this is the first one, finance use cases, most important one. And if you're going to see, there are 4 major blocks: wholesale or commercial banking, card payments, retail banking, and IT infrastructure. And all of them has use cases which are using predictive analytics to work. And it is interesting to also note that all of these industries, few years back, were just doing everything manually, and how the things have just changed. So know your customers, anti-money laundering, again, very important use case of finance to actually figure out which is the fraud that's happening in the financial sector. And I think this is very important use case, because a lot of companies are trying to actually come up with new technologies to help identify the fraud that is happening. But unfortunately, again, on the other side, the fraud is also, they're also using machine learning, again, technologies to actually do more fraud. So this is something that there's a close competition between the two. In retail banking, we have deposit fraud, we have customer churn, auto loans, IT infrastructure, security, cyber security. And if you talk about credit card or payments, you have transactional frauds, credit risk scoring. So these are the use cases where we are applying predictive analytics, and we have customers from all these different domains. So if we were to look here, you could say that these are just 3 challenges that companies were facing before they started using predictive analytics to solve their problems. So if you look at here, this is anomaly detection, and it's for finding network anomalies faster with predictive analytics. So if you were to see that mobile applications are critical to almost all the businesses today, and especially for credit and banking companies. And the mobile applications, they sort of represent a significant channel of interaction, because we can use our apps to do most of the banking today. But say if your app goes, it just shuts off, or there's a problem with your apps, then you're going to have real problem. And what anomaly detection does, it just finds the anomalies in these networks before it gives you an idea that, this network is going to be struck with some problem, maybe in this hours, and then you can take some measures before that. KYC or know your customer, again, this is it's a key component of your anti-terrorism legislation. And because if there's a failure in identifying a correct person, or this going to has repercussions. And if you were to see here, we understand the dynamics of the customer interaction with the help of predictive analytics. We take data, historical data from different areas, and we try and find whether this person has been involved in some suspicious activity, and it just flags it. And earlier, companies were using rule-based systems, so they had rules. This is so if the person has come to say US like 10 years, so it's okay. If he has a house, it's okay. If he's working, he's okay. But the rule-based system, they don't work, because because all these transactions, what happened, Hawala and everything, they're also pretty intelligent. And rule-based systems, they don't work here because things are changing pretty fast. And so now we have a combination of rule-based plus predictive analytics-based solutions that we are giving to our customers. And then this is the customer churn. Again, it just helps to retain valuable banking customers, and it gives you an idea even before the customer is about to churn, so that your relationship managers can actually work with the customer to understand the problems that the customer is facing and help to resolve. The second important case is the insurance case. And insurance case also has a lot of use cases, like the ones where you have to give the customer the next best offer. And this is a personalized sort of an outreach to the customer. And earlier it used to be just a mass thing where everybody was given the same offer. But today, depending upon the age of the person, depending upon whether he has a family or not, whether it has a job or not, you give personalized offers, and that has a more chance of conversion. Again, you have underwriting, risk segmentation, and again, customer experience, especially claims management. So in all these fields today, we are using advanced predictive analytics instead of just rule-based mechanism that was there just a few years back. This is a very important case of healthcare. So healthcare as an industry today is actually booming. And healthcare is just not limited to identifying diseases and doctors. No, there's much more to healthcare. And healthcare itself is turned into a complete business. So apart from the fact that you can detect cancer and oncology with machine learning and AI and predictive analytics, of course, seeing your parameters, there are other things also. For instance, product recommendation, personalized drug matching, even flu season prediction, identifying the season of the flu when the people are going to be struck with a particular flu, so that you can work on the vaccines beforehand instead of just waiting. Medical claim fraud detection. I think a lot of fraud happens in claiming medical claim, and it's a two-sided one. Sometimes the companies are struck by the fraud, and sometimes the patients are struck by the fraud, that they are actually genuine, but they do not get their claims resolved on time. And even so much, the analytics has gone so much advanced that we also use it for remote patient monitoring. And a very interesting data that we have is, it's called the crash, the ICU crash. So it said that studies show that patients who undergo an unplanned transfer to ICU, so they experience the worst outcomes than the patients that are admitted directly. So there are two categories of patients. One of them are who are actually ill, and that they have to be taken directly to the ICU. There are the other set of people who come for a normal checkup, and then after checkup, you identify you have this life-threatening problem, and you have to be admitted to ICU. And for this set of patients, it's very difficult for them. For the patients, it's difficult because they have to arrange a lot of, the fees for the ICU, which is very expensive. But it's also difficult for hospitals because they have to make beds available. And what we are using predictive analytics is to actually look at their parameters of the patients and identify from the symptoms and from the past data how much probability that of a patient has of crashing, and crash is a word for going into ICU. And so for instance, if a person comes from regular checkup, we're going to see the checkup reports for like past 1 year and see if he has serious heart condition. And then by discussion with doctors, you'll identify, this person has a strong chance or this person needs a bypass surgery maybe. So you need to tell the patient beforehand. And so in such cases, we're using predictive analytics. Waste in healthcare is another major problem, and if you see that it's a staggering $765 billion annually. So the money that's spent on disposing the waste, and one of the problems for wastage in healthcare is the unneeded testing, and we all are aware of the fact that a lot of times we have to undergo so many tests, and a lot of tests are not even required. So what companies today are trying to do is use analytics and machine learning to actually reduce the number of tests that is required for a patient. Not only will that reduce the burden on the patient, but will also help to contribute to the quality of care for the positive patient outcome. So you will only have to focus more on patients who actually deserve that attention instead of the false positives that you have around. So that is something that a lot of big healthcare institutions, they are working on to reduce the need for tests. And then there is this acquired infections called hospital or healthcare acquired infections called HAIs. So these are the infections which a person acquires in a hospital. And again, this is pretty dangerous because a patient mortality rates associated with this are like up to about 25%, and this also requires a lot of cost on part of the patient and also extra care from the hospital. So these are some of the use cases which the healthcare industry is using, apart from of course predicting whether a person is going to get a particular disease or not. So this is something pretty interesting. Then we have marketing use cases again. So these are the ones which people are aware about. So of course, you need to increase your sales with marketing, optimizations, ad placement, where you need to place the ad, where it has maximum chances of conversion, who is going to be your next best customer. So this is something which I think a lot of people already know about. Another area where predictive analytics is being used today is telecommunications. And it is a pretty interesting field to use predictive analytics because for telecommunication companies, finding and building customer relationships are key to creating a growing and a profitable business. And if you look at all the leading companies in the sector, they know that customer experience and streamlined operations, they're just key to a success. And to make sure they have streamlined operations, they use predictive analytics. For instance, if you are facing a phone or internet service issues in your area, and when a person has this, if a person has issue in any other service that they are using for any other company, the first thing is to call the customer care center. Yes. But what if they're not unable to call the customer care because there's a problem in the network or the telecommunication lines? So for telecommunication companies, this becomes a very big problem because you're not able to connect to them. And this will impact, of course, the support employees also, and they'll have low job satisfaction again because they're going to hear from the customers, after 2 or 3 days, and they're going to get shoutings from them without any fault of theirs. And again, there are certain organizations which sort of depend on a fleet of vehicles, okay, for doing their daily operations. And there are a lot of them today, even logistics companies. And what used to be the normal practice was the predictive maintenance. So predictive maintenance was after, like, say, 1 month, all the vehicles were given a haul over and it was checked. Now, some of them, they needed servicing, the others did not need them. But it was just after fixed amount of time. Say after 3 months, you'll get a check over, or after 6 months. The problem with such thing is There could be vehicles which are absolutely fine, and it makes no sense for them to go to garages. On the other hand, there could be some vehicles which could develop problems during the time when no maintenance has been assigned to them. So for such things, we use predictive maintenance so that, there's no specific time where the vehicles have to go for maintenance or servicing, but it depends upon particular vehicle to vehicle. And preventive maintenance strategies may replace parts that still have significant work life. So it used to be a waste of time and energy, but now it is more real time and it's individual vehicle based. So we've talked about a lot of use cases. We talked about how predictive maintenance is revolutionizing the industry, but we also have to understand the fact that there's still a lot of challenges in this field, and collaboratively and together we have to work on them. So in 2012, Google actually announced its ability to predict flu outbreak in US 5 days in advance actually. And it said that it could just identify 5 days before it would happen. And during that time, we could get the doctors and the vaccinations set up. But in 2015, actually, the CDC, they revealed that what Google was predicting was actually twice the size of the correct number. And that was like huge. And so what they predicted was not correct. And predictions like these, especially during healthcare, can be disastrous. But of course, Google has, from that time, from 2012 to 2020, there has been marked difference in capabilities of Google in machine learning and AI. But this is just one example of how things can even go wrong. And the recent example of what we are facing today in 2020 is how a lot of companies had their models completely break during the onset of COVID, because this was something which was never even envisaged that this would happen. So this factor was never taken into account when the models were created. And ML models, they always rely on historical data, but historically we never had a situation like COVID. And when it struck in 2020, it was just a once in a lifetime event, and everything went for a toss because the models, they never thought that such thing could happen. That doesn't mean that this undermines the importance of predictive analytics. It is an important factor for us to understand that next time we create a model, we also have to keep in mind that things like COVID can strike, especially in the restaurant business. There was a surge in the number of orders online because restaurants were closed. And the restaurants, they hadn't actually thought about this. So they needed more drivers, they needed more people. And the way the models were predicting the orders tripled, doubled and tripled. And even they did not know what to do. So it's not that COVID will happen every year, but now the next time we start creating a model, we also have to keep in mind that things like this could happen. Another case was for the image classification models. So now, because most of the people are working from home, so if you show a picture of a person working from home, that picture is recognized as home, even though, now that's an office now. So if you show a picture of a person working from home, it is actually shown by image recognition models as leisure time, but that's not leisure time, that's working time. So a lot of models will have to make a lot of changes. And it's a good thing because this will help us to create even better functioning models in the future. So we bring this all together. In this session, we talked about what is predictive analytics, why it is important. We went through some use cases and some of the industrial use cases, real life use cases, and also the challenges that come together when we use predictive analytics. So I'd just like to end this with a very famous epigraph, which actually captures the importance of analytics and data-driven decision in just one sentence. It just says, "In God we trust, all others must bring data." So all the companies can benefit from using predictive analytics. They can gather data on customers and predict next actions based on historical behavior. And then this information can impact the business bottom line and can also influence results. So it's a way that predictive analytics can just transform the way industries are working today. And that's all from my side. And I will take the questions now. Thank you.
Yeah, thank you, Ms. Parul. It was a beautiful session. Okay, I would open this session for a Q&A, and quickly, one of our students, Pramit, is asking, what is the best way to know why customers defaulted? For an example, in a bank.
Okay, so again, like I say, like I told you, you will actually have to gather data on that person. You will have to actually see what is the person's current income, what is the family that he's supporting, he or she is supporting, and what is the reason for which the person is taking loan. Because it happens a lot of time when people take personal loans, they have more chances of defaulting than when they take it for home loans, or when they take it for some, you could say, some business loan. So you have to understand what is his past behavior. Has the person taken loan beforehand? Or what is it that the person is trying to do? So you will have to collect data based on that person.
Thank you, Parul. Pramit, hopefully you have got the answer. I'll take up the next question from one of our colleagues, Professor Ankur Srivastava. He is asking, are quality data set available for machine learning in India? Especially secondary data sets are available, especially in healthcare and retail sector.
Yeah, so that's a very good question.
So probably he means quality of data availability. Yeah.
Yeah, so good quality data sets for Indian, specific to India, it's actually very, very less. We have also been trying to, and unfortunately what that happens is when we create a model, we use the data set, say for US, and we're using a model created for that population, and we're using that model to predict for a country like India, which has very, very different, you could say, population and behavioral differences. The problem with India as such is that a lot of data is not openly made available, and there could be a lot of reasons for that. As compared to countries like US and UK, not only they make the data available, but there are people who work actually to create data set only. And that is something that's lacking in our country, because if you talk about financial data sets, you will not find some good data sets, and it's just all hidden. So there's something that, and I think privacy is good. Of course, everybody needs privacy, but if everything is going to be private, we will not have anything to actually work upon and improve the current models. So yes, there is a dearth of good data sets, India specific.
Okay, hopefully Ankur got his answer. I'll take up one or two more questions from Sanjay, Professor Sanjay also. He has a couple of questions.
Professor Surjit, can I just, sorry to interrupt, but in line with that, my last question, I just want to ask what Parul said, that since we are just training our data sets on, training our models on the Western data sets, the problem is that utilizing those models for the Indian data, when it gets available, it goes through some problems. Now, one aspect is obviously the issue related with the kind of individuals on which the data has been collected. But another aspect which has also recently been cropping up is related to the systematic biases, which has been put up, which has been a lot a matter of concern, especially in Western areas where people are kind of putting certain biases. It can be not singling out, but there are biases. So how do you take care of that when you are like utilizing those models for Indian data sets?
So sometimes you have to create synthetic data sets, of course, because there is a huge imbalance because of that. And like you correctly mentioned,
Your voice is breaking, I guess.
Platform. And so we majorly, when we work with companies, we use their own data sets.
Ankur, any other question?
No, fine. Thank you. It was a wonderful talk.
Okay, I think Professor Sanjay also can interact. He can himself ask questions that he has put on chat window.
So first question, Parul. First of all, thank you very much for this very enlightening talk. All of us liked it. Now, is this driverless AI that you're talking about, is it open source or is it a licensed software?
So it's a license-based product because that's the product from which, so that's the only enterprise level product of H2. All other platforms are open sourced. But for academia, we give a license for nonprofits and for academia and for students and for professors. We give a free license so that if they want to work on their research projects, they can utilize it. So we are actually very much open to colleges and academia people to work with us using driverless AI.
That's excellent. That's excellent news. I think I'll get in touch with you for
yes. I'll definitely connect you with the team that's working on it because we would want you all and get your perspective and your feedback on the platform itself.
Another related topic is, now you said data creation itself is a big job, right? So data creation, I mean assembling all data and making one big data set which people can use. So can something be done where we can use students to gather all that data and make sense of it, in the sense tabulate that data? Is there something that can be done?
Yes, I think so. What like if I'll tell you about from my experience, what happens is when a company approaches us and they say, for instance, we are coming from a manufacturing, us as a manufacturing industry, and we want you to sort of create a model for us. And so we ask them for the data, and most of the times that data is like, it has a lot of important things which are missing. It's not in the right format. If it's not even the right amount, like we would at least want some 6 months data, and they'll give just 1 month data, and they say we do. And then most of the time they say, we never collected this data for this particular field. We don't even have data. And so I think it's also about tabulating the right amount of data, and also about educating the people who are actually collecting data, what to collect and what not to collect. So it has to be streamlined. So the people who are creating models and the people who are with the task of creating data sets, they have to be aligned actually. So they know that, they all are working for the same cause. So that is also a big major problem. And crowdsourcing, like you mentioned, I think it's a thing which is going on in the West, where students from colleges are helping industry to actually do crowdsourcing or creating data and putting into and helping them in all this. So a lot of in the West, it's becoming a common thing actually.
Okay. Now, where do you stand on this debate, open source versus licensed software? I would like to hear your views.
Yes, interestingly, our companies. So I think, so if you talk about my company, the two things that we have, H2O library and driverless AI, one is open source and one is closed source. So both of them can do the same work. So H2O open source library also has an AutoML component, which is, so it has H2O AutoML, which is open source. And then driverless AI is closed source. But driverless AI gives you a lot more capabilities, like I told you, auto visualization and things like that. And in order to create and maintain such a platform, it does require considerable amount of resources, and hence we have to make it payable. But the thing is, since it's B2B, so for companies, it's really helpful, because if you talk about big companies like Google and Facebook, they have their own machine learning teams. They have their own data scientists, best. But if you talk about, there's a small business owner, and the small business owner understands that machine learning today is important. For that owner to create a team from scratch, it's going to be really hard. You have to get PhDs and experienced data scientists, and so for them, such tools can help them also to make use of the technologies that the biggest companies are using. So what Google is using can also be used by a very small business owner. So that's the whole idea about enterprise-based ML solutions. The price is very less, I think, as compared to, and you can instantly get started. You get help from the companies which create, as opposed to if you were to create your own big teams and pay them salaries.
Okay. So I have a couple more questions. Before that, I just one more point. I think I read about this Guido van Rossum who
Yes,
joined
Microsoft.
Microsoft. He got tired of being retired.
Yes, so
Another
that's the power of programming and coding. I think you can work at any age.
good
You
for
can,
Microsoft, I think.
yeah, he was working for Google in the past, where he worked on a lot of, and then he went for retirement. And 64 years old, and he's joined developer segment of Microsoft.
Right. Two more questions. So what are the most important skill sets for MBA students to get into analytics? This is a question that we get daily. I mean,
Yeah.
all of us, all our colleagues get this question on a daily basis.
So now I think, because of course, if they want to get into analytics, they will have to have the know-how of analytics solution. But today, something good is that there are so many no-code solutions available in the market. So it's not necessary that you have to get and start scratching and start learning coding from scratch. You can also just understand how to work on a particular platform. And another and most underrated one, I think it's the storytelling capability or communication, because ultimately, even today, when we work with companies, ultimately we have to explain it to the business stakeholders. And for them, it doesn't matter what model you're using, it doesn't matter what accuracy level. Of course, that does matter for a person, but we have to explain them why this solution we think is the best for your company, and why this is going to help ultimately in your business and get more revenues. And for that, they have to speak in business language, communication, being able to explain what their idea is in very lucid form, and helping companies to understand a business problem, how it can be broken down into an analytical problem. That's the most important thing, and which I think a lot of people don't focus on, because they think you've coded, you've created a model, it's great. Ultimately, you have to stand up and give presentation only. So that is something that they should start working, I think, from very early on.
So last question, which part of the data science value chain does a data scientist spend the most time on?
Yes, it's again, so it is the data cleaning part very much. And also, I think it's also on the tuning of the models. That is also takes a lot of time.
Okay. And could you please share this PPT if
Yes,
if it's okay with you?
Yes, absolutely. I will.
So just sir, I'll just have a last question, more question other than query. Out of all the competing models, if you like get, does the model which you select is purely based on just its prediction power or anything else, any other parameters? It's kind of complicated issue, or it's just purely we come down to the prediction power of it. Let's, for example, simplistically putting it as a R-square value, and you can finalize that or something else.
So what that happens is, I think, of course, we know that the complicated models, they give better accuracy, of course, but sometimes what happens is, say for instance, if we are creating an app, and our model has to be then ultimately put into an app, and then we have to also keep in mind the latency. Even though the deep neural networks will give us the best accuracy, but they're going to, the computing power or the compute that they're going to use is a lot. And at times when we don't have a lot of compute power, we have to go with simpler models, because the latency is again an important issue when it comes to productionizing the models. You cannot take forever for a model to train and then give you the result. So it's always a trade-off between the two, and then you have to decide with your stakeholders what is that they want.
And I think related to this, Kaggle gives away prizes to people who make an efficient model and gives a faster outcome.
Yeah, so that is, I think, one of the things that it's a. So I think it's good on Kaggle. What you can understand is you can see what are the state of the art models that are happening. You can get an understanding of that, but then when you are using, you still go with a lot of simpler models, because if you're using ensembles and ensembles of models, it's going to take forever.
That's true. I am done. Thank you very much, Parul.
Yeah, thank you, Parul.
Thank you so much. It was great. And it was great interacting with all of you. And I hope the students have also benefited from this presentation. Thank you.
Thank you, ma'am. Thank you very much for sparing your valuable time. Yeah.
Thank you.
Thank you, Sanjay.
Parul,
Thank you, Sanjay. Thank you so much.
sorry, I'll trouble you for 1 or 2 minutes.
Absolutely.
Venu sir.
Yes, yes, please.
Bye. Thank you. Good night.
Yes, Surjit. Surjit, are we done? Sanjay?
Dr. Surjit was saying something.
Yeah.
I can't hear him now.
Yes, sir. Are we ending the session now?
Yes, I think we are. Yes, Sanjay, Shalinder?
Yeah. So, Parul, just a very specific question in case.
You could type it. Surjit, can you type? Voice break हो रहा है आपका.
Can't hear you.
Surjit, just type it there.
Sanjay sir, are we ending the session now, or we have got 1 or 2 more minutes?
Dr. Surjit, you can go ahead and ask your questions. She is here. She's here for a couple of
Yeah. So I was just checking with Parul. He has got 1 or 2 more minutes. Parul, I have a very specific question. I mean, I know this is a subject where many people would have many questions. Very specific question. How do you detect sarcasm in a text analytics?
Okay, so again, there are 2 ways of solving the problem. One is, of course, if you have previous labeled data and so one is going to be a crude classification method where you're going to use the prior knowledge that you have, and then you create a model based on that. And another which people are going is the real-time based, probably where you use NER technologies, where you see the relationship between different words. So earlier it used to be going to identify keywords, and if those keywords are sarcastic, you would flag that sentence as sarcasm or not. Today, it's also about the relationship between the words that are around that word keyword. If that gives you even a sense of sarcasm, say for instance, you say that the bag is too good. The bag that I brought from Amazon was so good that I had to use it for grocery the very next week. Now, this appears to be a very flagged question, and if you would traditionally see it, this would appear as a positive sentiment sentence. But now, if you were to use NER-based technologies, you would see that the 2 sentences, they differ a lot in their meaning and their sentiments. The first sentence is very positive, and the second sentence is pretty negative. And so if you see the difference between them in a single sentence, I think we mark it as sort of seeing the probability that it is a sarcasm-based sentence. Even though in NLP, still a lot of work is to be needed to actually, if you don't use GPT-3 and all, it's still way too much work that we need to have human-like intelligence in identifying.
So you must be working on similar projects, from some clients, like where you have to detect this sarcasm. Now, model-wise, how much accuracy you think this model? I mean, currently, whatever model we have got, how much it is accurate?
So I think even if we have a 70% accuracy, we consider it pretty good. And that's the maximum that we are having, because language is something that it's the way we speak. We in India, we speak a language is very different from what the people at US will speak. And so we would need a lot of India-based. If you're creating a model for India, then we would require a India-based data, because if you look at US, we would find a lot of people are always speaking in a sarcastic language. So that's also different. Our English will be different than their English. So we did work on one of them. We were getting about 74% accuracy, and we thought it was pretty good.
Okay, so I'm done. In fact, I have got a couple of more questions, but I think it's okay. I'm done from my side. So next proceedings, Venugopal sir, as you say.
Okay. Thank you, Parul, for being online, coming despite your hectic schedules. I'm sure your session would have added a lot of value to our students. And as faculty, we also have learned what industry is doing. I'm sure Sanjay and Ankur and others concur with my views also. But should we need your help in future in terms of wetting our syllabi, our short-term courses and all that, we would definitely invite you there. So kindly help us out in that arena as well. I thank Sanjay for introducing you to IBS. And I'm sure this has been a great session, Parul. I have learned myself a lot in this. And I'm sure our students also would have learned a lot. Thank you, ma'am, and have a nice Diwali.
Same to you.
Wish you the very best. Yeah.
Thank you. Thanks a lot.
Bye, Paul. Bye.
Okay, then can we log out?
Yep.
Yes. Happy Diwali,
Okay, everybody.
Happy Diwali.